All right, let's pull back the curtain on a hidden digital world, a cat and mouse game that's happening every single second online. Today, we're going to crack the case of the Selenium fingerprint. You know that feeling, right? You've written the perfect script, it runs like a dream on your machine, but the second it goes out into the real world and hits a website, poof, it just breaks. No error, no warning, just a brick wall. Well, I'm here to tell you that probably wasn't a coincidence. See, modern websites are armed with some seriously sophisticated anti-bot systems, and they are constantly on the lookout for automated traffic. Your script didn't just fail, it was spotted. It was identified, fingerprinted, and then blocked by a digital detective. So every time an automated browser, like one controlled by Selenium, visits a website, it leaves behind this trail of invisible clues. Think of it like a ghost trail. These aren't things you can normally see, but to the website security systems, they basically glow in the dark. This whole collection of clues has a name, the Selenium browser fingerprint. It's a unique signature, and it's made up of dozens of these tiny little giveaways that all come together to scream, "Hey, I'm a robot." Understanding this fingerprint is absolutely the key to figuring out why your automation might be getting shut down. So how exactly did these digital detectives do their work? Well, they have a whole toolkit of techniques designed specifically to uncover these telltale signs of automation. Let's dig into that toolkit and see what they're actually looking for. Sometimes the simplest checks are the most effective. The biggest, most obvious clue is the navigator.webdriver flag. In a standard Selenium session, this is set to true. That's like walking around with a giant neon sign that says, "I'm a bot." A normal browser, it doesn't even have this property. And it's the same for other things like having no browser plugins or an incomplete window.chrome object. These are super easy giveaways for any detection script. But, it gets much, much more sophisticated. Websites can actually ask your browser to do little tasks in the background, like rendering a hidden piece of text with Canvas. Because of tiny variations in your specific graphics card and drivers, the image you render is unique to your machine. This creates a digital signature, a hash. The same exact thing happens with 3D graphics using WebGL. Automated browsers, especially when they're in headless mode, they produce identical machine-perfect hashes every single time, which makes them really easy to spot. And beyond all the technical flags, websites analyze your behavior. Think about it. Humans are messy. We don't move the mouse in a perfectly straight line from point A to point B. We don't type at a constant 300 words per minute. Bots do. And ironically, their mechanical perfection is their single biggest giveaway. Okay, so if websites are the detectives, how do we become the spies? The logical next question is, how do we hide our bots? This brings us to the other side of the story. The art of the digital disguise. The first and most common step is to deal with that smoking gun we talked about, the navigator.webdriver flag. By using some specific browser launch options and then injecting a tiny piece of JavaScript right when the page loads, you can basically tell the browser to lie and report that the WebDriver flag is undefined, just like a normal human-driven browser would. Now, manually patching everything is a huge hassle, which is exactly why people created specialized libraries. Tools like Undetected Chrome Driver are literally drop-in replacements that automatically handle a ton of these patches for you. And then you've got newer libraries like Playwright, which is already known for having a smaller detection footprint right out of the box, and it gets even better with its Stealth plugin. For the really tough targets, you've got to go deeper. This means doing things like adding random noise to those canvas outputs so the hash is always a little different, or even spoofing your graphics card information. But honestly, the most crucial part of any good disguise is consistency. If your user agent says you're on a Windows machine, but your platform details are screaming that you're on a Mac, well, your cover is blown. Everything has to match. But here's the catch. For every clever new evasion technique, a clever new detection method gets developed. This is not a problem you solve just once. It's a constant, escalating arms race between the people building automation and the anti-bot systems. And the opposition here is serious. We're talking about major players like Cloudflare and Datadome, companies whose entire business model is based on detecting and blocking automated traffic. They're using machine learning, they're analyzing hundreds of data points in real time. Bypassing them is incredibly difficult. And that really brings us to the core of the problem. The second you think you finally figured it out, a new Chrome update is released, all your patches break, and the anti-bot systems have already rolled out a new way to detect you. It's a full-time job just to try and keep up. So, given this constant battle, how can you play smarter, not harder? Let's get into the best practices and the professional approach to try and stay ahead of the game. Okay, Here are the key takeaways. First off, just avoid headless mode for any site that's protected. It's the easiest target to spot. Always randomize your timing and simulate real mouse movements to look more human. And this is crucial. Make sure your entire digital identity is consistent, from your user agent all the way down to your IP address's time zone. Oh, and using data center IPs is a huge red flag, so try to stick to residential or mobile proxies. But for the really serious, mission-critical automation work, a lot of professionals are taking a totally different strategy. They've basically decided that the best way to win the arms race is to not even participate in it at all. This really presents two different paths. On one side, you have manual patching, that constant, exhausting cat and mouse game. On the other side, you have professional cloud browsers. These services don't just patch an automated browser. They give you access to a real browser running in the cloud, one that has no automation flags to begin with. They handle all the fingerprint management for you, automatically staying one step ahead of all the detectors. And that leaves us with one final big question to think about. When it comes to your own projects, what's the better strategy? Is it spending all your time and energy trying to build the perfect, unbreakable disguise, knowing it might be obsolete tomorrow? Or is it better to use a tool that lets you show up without needing a disguise in the first place? The choice, of course, is yours.